Hello everyone, welcome to my YouTube channel Learn with Lakineni. So since last two videos I'm explaining you about the basic concepts of Python, the fundamental concepts of Python. So I hope you are all enjoying my videos. So please subscribe to my channel Learn with Lakineni and please like my videos and share my videos so that so many students will be benefited, so that these videos will be useful for their career point of view. So please subscribe to my channel and please like, share and comment so that your comments, your feedback will be useful for us to update us. Now in this video, I'm going to explain you about what is a Boolean data type, what are the float data type, so what is a complex data type, what is a range data type. In the previous video, I have explained what is an integer, what are the various representations of integer, how we can represent an integer number in terms of hexadecimal, octal, in terms of binary number, how we can convert from one number system to the another number system, and what are the predefined functions available for representing hexadecimal number, for representing octal number, for representing binary number, and what are the various ways of converting from one number system to the another number system. So these are the things which we have discussed in the previous video. In this entire video, you will discuss what are the float numbers, what is a Boolean, and what is a complex number, and what is the range, and what are the different forms of range. So these things will be discussed in this video. So please listen the video properly and please practice the examples which I am giving in the video so that it will be more useful and you will get hands-on knowledge on Python.
Physics. Okay, up to this it is okay. And also you can see whether you have some shortcut method to see whether two memory addresses are same or not. Here you can write A is B. Is the operator which checks whether the memory address of A and memory address of B are equal or not. Are equal or not. So if both are equal, it returns true. If both are not equal, it returns false. Suppose if I run the code A is B, what it is showing? It is showing false because the address of A and address of B are different. That's why it is showing false. Suppose if I write C is equal to 14 and D is equal to some 14. Suppose if I write C is D, then C is D. What is showing? It is showing true. Why? Because the address of C and address of D are same. That's why the value written by is operator is true. Okay. Here one thing. Your friend asked me a question that, sir, suppose if you write A is equal to B is equal to C in a single line assignment is equal to 10. Suppose if you write A is equal to B is equal to C is equal to 345 or something, you write some 500. A is equal to B is equal to C is equal to 500. Okay, I have executed the statement. So that means you are allocating the 500 value for the variable A, for the variable B, for the variable C. So A, B, C are having the same value, but the value 500 is not in the range of 0 to 256. So what you will think? So your Python interpreter will allocate three different memory locations for A, B, and C. Like previous. In the previous case, what happened? A is equal to 345, B is equal to 345. The address of A is different from the address of B, even though the values are same. Here also you will expect A is equal to B is equal to C is equal to 500. That means 500 is allocated to A, B, C. But 500 is not there in the range of 0 to 256. That's why those three memory locations are different. Suppose if I want to see the address of A, the address of B, the address of C, you can see all the memory locations are same. They are sharing the same memory location. Are you getting or not? Here, what I have explained in the previous class is completely contradictory to what happened here. Okay, now you please listen carefully. When you are allocating a same value to different variable at different times, then your Python interpreter will allocate same memory location if the values are between 0 to 256 and different memory location if the value is above 256. That is the case happened in the first example. A is equal to 345 and B is equal to 345. A is equal to 345 and B is equal to 345. You have allocated at different times. You allocated 345A to some time and you have allocated 345B to at some other time. So that's why these two values are same, but they are assigned at different times so that this 345 is not in the range of 0 to 256. That's why your Python interpreter allocates to different memory location for the same value. When you come to our last example, A is equal to B is equal to C is equal to 500. You are at a time allocating the 500 value to A, B, C. In this case, the Python interpreter will create an integer object, that means an integer memory location. In that integer memory location, this 500 will be stored and that object will be referred by variable A, variable B, variable C. That is the reason you got a same memory address for A, B, C, even though the value 500 is not in the range of 0 to 256. I hope everyone is understanding. You please be clear about the small concepts. Simple. There A is equal to 345, B is equal to 345. Both are having the same value, but not having the same memory address because they are not in the range of 0 to 256. But here also, you are assigning A is equal to B is equal to C is equal to 500, but they are having the same memory location. How? That means this is called as A is equal to B is equal to C is equal to 500 is called as single line assignment. That means you are assigning a single value to a multiple variables in a single statement. So whenever you are assigning a single value to a multiple variables, then Python interpreter automatically creates a single object memory location, and that memory location will be shared to all the variables which you have given in the single line statements. That's why here A, B, C are sharing the same memory location. Okay. Here I have explained you one new concept, that is operator is. A is B. A is B indicates whether the two variables are having the same memory location or not. Every time you don't need to check ID of A, ID of B. Suppose you want to see whether A and B are having the same memory location, then you have to type ID of A and ID of B. You don't need to check like that. You just simply write A is B. Is an operator which checks internally the address of A and address of B are equal or not. If both are equal, it returns a value true. If they are not equal, it returns a value false. I hope everybody is observing the running code. Okay.
Sir.
Hello.
Sir, Lekasrin add
admitted. I am watching.
Okay.
Have admitted. Okay. So I hope Santosh, your doubt has clarified.
Yes, sir.
Okay. In single line assignment, your Python interpreter will give only single object memory location, and the remaining variables will be shown to the same memory location. But when you allocate same value in different times to the variables, then definitely you will have different memory addresses. Okay.
Okay, sir.
Okay.
Thank you.
Now I have already explained. You can store the integer values in either in direct integers, or you can store directly in binary values, or you can store in what? Octal values, and you can store in hexadecimal. Okay. Suppose if I write some C is equal to 0B11011. So what type of value it is? You are storing a binary type of value in variable C. But if you want to print the value of C, you will get the integer value only. You may give binary value, you may give octal value, you may give hexadecimal value, but finally all the values will be internally converted into an integer type. Finally, when you want to print the value of a variable, okay, in single line assignment, your Python interpreter will give only single object memory location, and the remaining variables will be shown to the same memory location. But when you allocate same value in different times to the variables, then definitely you will have different memory addresses. Okay.
Okay, sir.
Okay.
Thank you.
Now I have already explained. You can store the integer values in either in direct integers, or you can store directly in binary values, or you can store in what, octal values, and you can store in hexadecimal. Okay. Suppose if I write some C is equal to 0B11011. So what type of value it is? You are storing a binary type of value in a variable C. But if you want to print the value of C, you will get the integer value only. You may give binary value, you may give octal value, you may give hexadecimal value, but finally all the values will be internally converted into an integer type. Finally, when you want to print the value of a variable, you will get a integer type value only. You cannot get any, you won't get any other types. That means binary, octal, or hexadecimal values. Similarly, you can use int function, you can use bin function, you can use oct function, you can use oct function, and you can use hex function to convert from one format to another format. Any format to any format you can convert. This is already I have explained. Suppose if I write bin of I am writing here an octal number. Here I am writing an octal number, some 4, 2, some 3, 6. Then immediately your octal number is converted into a binary number. Why? Because bin function converts the given number into octal number. Binary number can be recognized with a prefix 0 small b or 0 capital B. Either you can use either small b or capital B. So here case sensitive, it is free from case sensitive. And also in the hexadecimal, you can use 0 x or 0 small x or 0 capital X. For the octal number, you can use 0 small c or 0 small o or capital O to represent octal numbers. Okay, so this is about integers. So when you go to the floating point number, in floating point number, there is no such case that two same floating point numbers will have the same memory location. So in floating type of numbers, the concept is not applicable. Suppose if I write A is equal to some 13.45 and B is equal to some 13.45. So these two 13.45 and 13.45 is float numbers. You have given the same 13.45 value to two variables, but the memory locations are not same. You can simply see A, if you ask A is B, then it is returning false. That means the memory address of A is completely different from the memory address of B. Okay. So memory address of A is different from memory address of B. That's why if you ask a question, A is B, that means the address of A is equal to address of B. No, it is returning false. So what is operator is returning what type of value? Is operator is returning an address checking and Boolean value. It is checking the address and it is returning the Boolean value. Okay. So there is nothing much to know about floating point numbers. Have you seen
Sir, sir?
Yes.
Small doubt.
Yeah, tell me.
Sir, A equal to B equal to 13.45 anste appudu
A is equal to your
equal
dot,
to B.
okay, see, your dot will be clarified. A is equal to B is equal to 13.45. Okay, good. Okay, now you write A is equal to B, then you just run it. What it gives? What value you got? You got true. That means the memory address of A and memory address of B are same. That means when you are giving a single value to the multiple variables in a single line statement, interpreter. Why? Because I'll tell you one good thing once you please listen. Suppose if I write a is equal to 14, a is equal to 14, Python has some reverse process. In all languages, suppose if you write int a is equal to 10 in C language, first compile will recognize variable a as an integer type. Okay, the programmer intention is that a is a type of value integer. So that for that integer value, I have to give 2 bytes of memory location. In that 2 bytes of memory location, your 10 will be stored. That means left to right. Are you getting my point or not? First variable will be identified. Then according to the variable type, your value will be stored in the memory location. Why? Because according to the variable type, your compiler in C, your compiler in Python, your compiler in Java, or your compiler in C++ will create memory location. In that memory location, that a is equal to 10 value will be stored. But when it comes to the Python, it is completely reverse process, right to left. That means you have given a is equal to 10. Your Python interpreter cannot directly put the value of 10. You cannot identify what is the value, what is the data type of a. The Python interpreter first checks what type of value you have given. That means from right to left it will be identified. That means first it takes 10 value. Okay, programmer has given the value 10. So it is an integer. So for that integer, I have to create an integer object. For that integer object, I have to assign this variable. So like that, a reverse process will be happened in Python compared to the remaining language. In remaining language, first a variable will be identified of particular data type. For the data type, memory location will be created. In that memory location, your value will be stored. But when it comes to the Python, first a value will be identified. Why? Because it is dynamically typed. That's why we are calling Python as a dynamically typed language. Because you are not mentioning whether a is integer type or float type. You are simply saying a is equal to 14. So Python internally recognizes 14 is an integer value. For that, it creates an integer memory location. That means an integer object. For that integer object, your variable name a will be referred. So it is completely reverse process. That's why now I am coming to your question. So whenever you are giving a is equal to b is equal to some 12.45, that means first your 13.45 will be identified as an floating object. For the floating object, floating memory location will be created. In that floating memory location, 13.45 will be stored. Later, this A and B will be referred to the 13.45. So once you see, I am sharing the whiteboard. It is very good concept. First, you learn the very basic internal concepts. Suppose you are giving A is equal to B is equal to some C is equal to A is equal to B is equal to C is equal to some 13.5. So you are assigning a floating value to variable A, B, C. But compiler won't come from A, B, C. It doesn't want who are A, B, C. It is checking about what is the value of 13.45. That means it recognizes 13.5 is a floating point number. So it creates a floating point memory location. In that floating point memory location, that means floating point object, your 13.5 will be stored. Later, after that, your A, your B, your C will be referred to the same value and same memory location. That's why when you want to see the address of A, B, C, all the three addresses are same. Okay, suppose when you write A is equal to, suppose if you write A is equal to 13.5, B is equal to 13.5. Here you don't get the same memory location. Why? Because when it is running the first statement, it recognizes 13.5 is a floating point number. So for that, a floating object will be created, and that floating object 13.5 will be stored and this A will be referred to this 13.5. Again, when it is executing the next statement, B is equal 13.5. Again, a new floating object will be created in that memory location. 13.5 will be stored, and your B will be referred to the 13.5. So that's why the idea of A is different, the idea of B is different. Are you getting my point? So that's why it is showing same memory location when you are assigning the single value to the multiple variables in a single statement. It is showing different addresses for the same value. If you store the same value to the multiple variables at multiple times, that means here A is equal to 13.5 is one time, and B is equal to 13.5 is another time. It is happening two times. When it is happening two times, two memory locations will be created. But when you come to the when you come to A is equal, B is equal to C is equal 13.5, so it is happening at the same time. That means first memory location will be created. For that memory location, A, B, and C will be referred. So that's why it is showing the same memory location. Okay, so it may be an integer or it may be a float. When you assign the same value when you assign the same value to the multiple variables in a single statement, definitely you will get the same address. But if you give the same value to more than one variable in different types, definitely you will get different memory locations. I hope everybody is getting. Okay. Okay. So this is about float type. Okay. Floating point numbers can be used in scientific calculations also. You cannot represent you cannot represent hello you can represent a decimal value, a binary value, an octal value, an hexadecimal value in integer in type, but you cannot represent float using either float either binary type or hexadecimal type or octal type. Suppose I'll show you one example. Have you seen the screen? Suppose if I write f is equal to some f is a floating point number, f is equal to some 0b. 0b is an binary number. So 0b 111 some point 011. Suppose if you write, so you can see the error. Invalid syntax. That means you cannot represent binary value, octal value, hexadecimal value in terms of a floating point number. Floating point number always requires direct floating number, but not in other forms like binary representation, octal representation, or hexadecimal representation. Okay. Next concept in next data type is complex data type. So we know what is the integer type, we know what is the floating type. Next another one is complex data type. So you have not seen this type of data type in anywhere in C language, C++, or Java. But whereas this is possible in Python. That means you can represent the complex numbers in Python. You know what is a complex number? A complex number is in the form of A plus BI. So where A is a real number, where hello, are you getting my voice?
Yes, sir.
Hello? Okay. So where A is a real number and B is a imaginary part. B is an imaginary part. Suppose if we take suppose if what is the complex number? A plus BI. This is called as complex number. In Python, instead of B, it is J. It will be shown in terms of a plus BJ, where A is a real number, where A is a real number, and B is an imaginary number. This is called as real part and this is called as imaginary part. Okay, so this is called as complex number. Suppose if you want to store 5 plus 3j, yes, you can store in a 5 plus 3j in a. Suppose if you want to store a complex number in a variable, yes, you can store a complex number in a variable. So here a is some important information you need to know about complex also. Complex data types also. Once you can see, just I will show. See, so already I have given one example. So a is suppose if you write a is equal to some 12 plus and some 13j, then if you press enter, then if you want to see the uh, type of b, then it shows it is a complex number. So here your 12 is a what is called real part and your 34 is called as an imaginary part. Okay, so here there are important things you need to know about complex numbers. Here I'm showing on this screen. See here, you can represent how many parts are there in a complex number? There are two parts. One is real part and second one is imaginary part. In real part, you can represent the integer value or decimal. You can represent the int value with the help of decimal value, with the help of octadecimal value, with the help of binary number system, or you can use hexadecimal system. So in complex number, the imaginary part can be represented either directly the number, or you can represent the integer number by using what is called binding format, or you can use the octal format, or you can use the hexadecimal format. So here I'll show you one example. But when it comes to the real part, you have to represent only in directly either in integer format or in floating format. No other format is accepted in imaginary part. Suppose if you see the example, suppose if I am writing a is equal to some 10 plus, suppose if I write a is equal to, I am representing the real part with the help of some binary number system. 0p 111 01 01 plus and 10.5j 10.5j. Now I have run the complex number C. I have stored the complex number in C. Suppose if you want to see the value of C, so what is the value you got? You have given binary number in real part, but when you want to see the value of C, you got only the integer number system. That means in complex number systems, for the real part number, you can represent the real part number either using integer number system or you can use binary, octal, hexa. But whatever format you give, but finally the result will be converted into an integer part and the integer equivalent will be shown. So are you able to see? Suppose if I write d is equal to some 0 capital O, suppose 2352 plus some 13.7j. I have compiled this. Now I want to see the value of d. But even though I'm giving the real part in terms of an octal system, finally the octal system is automatically converted into a binary system and the binary value is printed. That means 1834 plus 13.5. So this is possible only with the real part. You cannot keep either octal, decimal, hexadecimal in imaginary part. Suppose if I write E is equal to some 34 plus I'm writing here the binary number system 0b 1101 and j. Suppose if I run, it is showing that it is an invalid syntax. That means no other system is allowed in representing the imaginary part. Only you can represent the imaginary part either directly by integer system or by floating point system. But no, you cannot give either binary or you cannot give either octal system or hexadecimal system. I think you are seeing the example on the screen. Suppose if I write e is equal some f is equal to some 0x, that means I am representing the number in hexadecimal system. F A C E plus 13.7 J. Now I run the variable x. Now I want to print the value of f. So the value of f is shown in terms of 64206. That means the decimal equivalent of hexadecimal 0x FACE is 60206. And the imaginary part is all having only floating point number. So that's why there is no problem. Okay. Suppose you can represent a complex number like this also. So C is equal to, suppose you can convert any number system to the complex number system. Suppose if I write COMPLEX complex of suppose if I write complex of 5, then if I run, you can see the complex number. Here I have taken the function complex. In that complex I have given one value, that is 5. So now I have run that. It is converted the integer number into a complex number 5 plus 0j. That means 5 is an real part and 0j 0 is an imaginary part. Here their imaginary part is not there. That's why the imaginary part is represented in terms of 0j. That means you can convert your integer number into a complex number system. Suppose if I write complex of some 45.6, then if you run, then it is showing the value as 45.6 is an real part and there is no imaginary part. That's why the imaginary part is being represented in terms of 0j. So you can also write like this COMPLEX complex of, suppose if you have both real part and imaginary part, then also you can represent you can send the real part and imaginary part as like this. So 12 comma some 45. Suppose if you run this code, then you can see the complex number as 12 plus 45j. That means 12 is an imaginary real part and 45 is an imaginary part. That means either. So have you seen the complex number? So you can represent the complex number simply, and you can send any value into the complex function, and you can send two values. One is the real part and another one is the imaginary part. Then it will be automatically converted into a complex number system. Okay. So suppose if I write complex, suppose complex of 0b1011 comma 12.5, you just run this, then also you are getting the complex number. So see here in the complex function there are two arguments, a comma b. In place of a, I have given a binary number. That binary number is automatically converted into an integer. So that is 10 plus 12.5j. Okay. Suppose if I write like this, COMPLEX complex of 12.5 as a real part and 0b11 separately the imaginary part. In a complex number, if you want only the real part, you have to mention the variable name with the real. That means c dot real gives the real number. C dot image, image means imaginary. C dot imaginary gives the imaginary part of the complex number. Are you understanding? Suppose if I write D is equal to some 335 something plus some 456 J. If I run, I want only the imaginary part, the real part of D. How can I see? So D dot real. Then I will get only the real part 345. Suppose only I want the imaginary part IMAG. Then you put. Then you got 56. Okay. So that means you can combinedly take the complex number, or you can separately take the imaginary part and the real part of the complex number. Okay. The next type is The next one is Boolean type. So what is the Boolean value? Hello, what is the Boolean value? Either true or false is called as Boolean data type. So in Python also, in like C, C++, Java, here also you have Boolean data type. So there are two types of values. One is true, second one is false. Okay. So only true and false are allowed as a Boolean data type. So Boolean type also you can represent any value into Boolean type and Boolean value into integer type. You have typecasting, that means type conversions. Boolean value to integer type or any value to the Boolean type. I'll just you see, I'll show you. So what are the Boolean values? True and false. How to represent the Boolean value? You have to give, suppose if you want to assign a Boolean value to a variable a is equal to write true. Boolean value true and false should start with a capital letter. In true, the T is capital letter. In false, F is a capital letter. So a is equal to true. So if I want to see the type of a, T by P, type of a. So what is type of a? It is a Boolean. Suppose if you want to give false, B is equal to FALSE, false. Wait. Wait, I'm writing spelling. Sorry. B is equal, I'm not
Capital
writing
F,
capital letter. Okay. So you have to represent B is equal to false. So if you want to see the type of B, it is showing it is a Boolean type. So true and false are Boolean type. Suppose if I write C is equal to within course true, within course true, and run and see the type of C, then it gives it is a string. It is a string. Or suppose C is some D is equal to some D is equal to FALSE, false. Then run it. Then if you see the type of D, it is showing what type it is. It is a string. It is a string. That means if you want to represent the Boolean values true and false, you should not represent within double quotations. Whenever you are representing the true or false within double quotations or single quotations, the Python interpreter internally treats it is a string but not a Boolean value. So Boolean value you have to give the Boolean value directly like this. TRUE. C is equal to TRUE. Then it will be a Boolean value. Suppose D is equal to FAA, false. So then it is a Boolean value. Suppose if you want to see the type of C, it gives the Boolean value. If you want to see the type of D, it gives the Boolean. It shows the type Boolean. But you should not include single quotes or double quotes for true and false. In true and false, the starting letter should be capital letter. So capital. Suppose if I write T is equal to TRUE. So what happens? TRUE. Suppose if I write what is happening? What it is saying? True is not defined. That means you cannot store directly a string type of value into a variable. That's why it is saying that true is not defined. But you are saying that true is a Boolean type. Where is the problem? The Boolean 2 starts with a capital T, but here I have not given the capital T. So automatically the Python interpreter thinks that true is some label or true is some variable. It is not defined, but you are trying to put the value of true in C. So that's why it is asking that name true is not defined. Okay, so definitely make sure to write a capital letter for true and capital letter for false. Okay. Suppose if I write I want to convert the Boolean values true and false into integer type. I want to convert the Boolean values true and false into integer type. Suppose if I write int of TRUE, int of true, then you just type it. What value you got? you got the value 1. That means in integer format, the value of true is equal to 1. Suppose if I write int of false, int of false, then you run it. In integer type, in integer format, the value of false is 0. Okay. So that means we have converted the boolean values into integer type using the integer function called int. Suppose if you want to convert the boolean value into bin, suppose write bin of true. So what is the value you got? You got the boolean, the binary equivalent of true. True is equal to 1. So 1 binary equivalent is 0b1. Okay. Suppose if I write bin of false, then you run it. You got the binary equivalent of the false. The binary equivalent of false is 0. So 0 equivalent of binary number is 0b 0. 0b 0. Suppose you can also convert oct of true. You can also represent oct of true. So it is representing the octal representation of true. Okay. So finally, the true value is 1. One value will be represented in binary number system, or in hexadecimal number system, or you can represent in octal number system. From any number system to the any number system. Okay. Suppose if I write similarly, you can represent any number into the boolean type. Suppose if I write bool of 12, can you say what is the answer for this? Suppose if I write bool of 12, so that means I am trying to represent, I am trying to convert the integer value 12 into boolean type. Is it possible?
True.
Is it possible to convert the integer value 12 into boolean type? Just see the answer. So what is the answer you got?
True.
You got true is the answer. Suppose if I write bool of minus something, so what is the value you got? What is the value you will get?
True. True.
So here also you got true. Suppose if I write bool of bool of 0, what value you got? Bool of 0 is equal to false. That means except 0, any number will be treated internally as true value. For 0, it is treated as 0 false. Okay. Any value, it will be treated as 1. That means it is true. Except 0, any value, if you give, the boolean function will treat it as a 1 and it will be shown as a true. But when it comes to the 0, 0 will be shown as a false. Okay. Are you getting? Suppose if I write bool of 13.4, what is the value will get? Bool of 13.4. Can anybody? So true, already explained.
True.
So any value except 0 will be taken as a true value. Okay. Suppose if I write bool of minus 678. So what is the answer you get? The minus 678 is converted into a boolean type of true. Okay. Suppose if I write bool of 10 plus 12j. So what is the value you got? In the boolean type, I have given the complex number. So it is a complex number. That's why the value is converted into true. Except 0, everything will be converted into true type. For 0, it is showing it as a false type. Suppose if I write bool of something, bool of ABC, then you see the answer. What is showing? Why showing? ABC is not defined. Why? Because ABC doesn't have any value, so that I cannot convert the ABC value to the bool type. Suppose if I mention bool of ABC, that means I have given the string type of value to the boolean function. Now you see the value. So what value got? True. That means string also it is converted into a boolean value, which is called as true. Suppose if you don't give the quotation, it will say that ABC is not defined. If you given the quotations, then the string literal is treated as a true value. Suppose bool of HOD. Okay, so what is the written value? The written value is true. Am I right or wrong? Are you getting? That means you can convert integer value into boolean type. You can convert your binary hexadecimal and octal value into bool type. You can convert a string also into a bool type. Suppose if I write bool of so this is Python class. Then if you run this, so what it is showing? It is showing the type it as a true type. Okay, these are very basics and very important when you are writing some competitive exams using Python. Are you getting? So this is about bool data type. Okay, I'm not simply explaining what is the bool. Bool means true and false. I'm explaining all the things surrounding by bool. Okay. Suppose another thing I'll tell you. Are you able to see the screen? Suppose if I write true. Suppose if I write the true plus. Oh, tell me the answer. 2 plus 2. Can you tell me the answer? 2 plus 2. Hello.
1.
2 plus 2 is
1.
1.
1.
Are you sure? See the answer. What is the answer? What is the answer you got after adding 2 plus 2?
2.
2. Why? Because internally compiler treats the value of true, and you are thinking that true and true are two strings. This is not string. Compiler will treat true value as 1 and the true value is 1. 1 plus 1 is, that means automatically your boolean value is converted into an integer type. That means 2 plus 2 is equal to, and 2 plus 2 is equal to 2. Suppose if I write a false plus false, what is the value you can expect?
0.
So you will get false plus false is equal to 0. Suppose if you write false
Plus true.
false plus true.
True.
So what the value you got? False plus 2 is
1.
not true. False plus 2 is equal to
1.
here you are not doing an OR operation. True false is true. So the first value of false is 0. The second value of true is 1. So that you got what is the value you got?
1.
1. Okay, I am just now for fun I am writing one thing. Suppose bool of 123 plus bool of minus 45 plus bool of some. Can you tell what is the value? Can you tell what is the value? You will get bool of 123 plus bool of minus 45 plus bool of
3, sir.
Can you do you see the answer? What the answer you got?
3.
What the answer you got?
3.
Already explained. Why? Because your integer value is except 0, the integer value, all values will be converted to true. True means 1. Suppose if you write, see here. Suppose if you write bool of 123 and you press, what is the value you got?
True.
True. But when you are adding, the true value will be entirely converted to 1.
1.
1 plus 1 plus 1. Okay.
1 plus 1. 3.
Have you got? Suppose bool of HOD plus bool of CSC. So what is the value you will get? You will get value 2. You will get value 2. Why? Because all strings will be automatically converted into a true type. True means the value written by true is 1. So the bool of HOD gives 1. Bool of CSC gives 1. So bool 1 plus 1 is equal to 2. Okay? Are you understanding?
Yes, sir.
So don't think that class is going slow. I'm telling many concepts. You don't find all these things. Okay. We'll go slow and we'll learn a lot of topics in Python. Suppose if I write some 1, 2, 3. Suppose Can you tell what is the value written by this? Bool of 1 to 3 plus bool of 0.
1.
The value got 1. Why? Because even though you mentioned here 1, 2, 3, but that 1, 2, 3 is shown in double quotations. That means that 1, 2, 3 will be taken as a string. So string means it gives 1. So bool of string means it gives true. True means 1. Bool of 0. 0 means false. False means 0. So 1 plus 0 is equal to
1.
1. Are you getting interest or not?
Yes, sir.
Are you seeing the live code execution?
Yes, sir.
Is it comfortable like a class?
Yes, sir.
Huh?
Yes, sir.
Surely I'll satisfy you in Python classes. I'll take more classes in Python. Okay. So by the completion of May 31st, we'll cover more syllabus. Okay. So this is about bool. Okay. So still how much time is there? Still 5 minutes there. In that 5 minutes, I don't go with another concept that is called as typecasting. I'll cover another more interesting function, another more interesting data type or function of Python is range. How many of you know range? So range is a function, or range is an iterative word in which you can create a series of numbers. Through the range function, you can create a series of numbers. Okay. Suppose if I write range of 10, can anybody say what is range of 10? Can anybody say range of 10? Suppose if I run, what it is showing?
0 to 9.
0 to 10. That means range gives the values from, if I don't mention anything, if I write simply range of 10, it gives the values from 0 to 10 minus 1. That means 9. 10 minus 1. That means 9. So range of 10 means it gives 10 values, but from 0 to 9. But from 0 to 9. Suppose if you want to see the values of 0 to 9, suppose if I execute range of 10, it is showing the output as range of 0, 10. But it is not showing 0 to 9 values. In order to show why? Because range creates a series. A series can be seen only with the help of an iterative loop. That means either you can use while loop or you can use for loop. Then only you can see the values of. You can take the values of the values from the range. The values from the range. See here. Suppose for I in range for I in range 10. That means for each value of I in range. That means range creates several values from 0 to 9. For each 0 to 9, I want to print those values. PRA and print I. Then you just run it. So what are the values you got?
0 to 9.
0 to 9. For I in range, that means for each value of range. For what is each value of range? How many values are creating by range? 0 to 9. How can you retrieve 0 to 9? With the help of a temporary variable I. So that means for the first iteration, 0 will be stored in I. That value you are going to print. In the second iteration, one value will be printed in I. That value you are going to print. In the third iteration, 2 value will be stored in I. That value you are going to print. In the third iteration, like that, till 9 you are printing all the values. Okay. So suppose range for I in range some 25. For I in range 25. PRA and print I. So what values will be printed?
0 to 24
0
values.
to 24.
0 to 24 values.
24.
Okay, na? So sometimes you can give the range a single variable. Suppose A is equal to range. Suppose A is equal to range of 10. A is equal to range of 10. So now I am writing for I in A. Here I am not writing range. Why? Because already the range of values assigned to the variable I, variable A. So for I in A, print I. So what is meant by range of, what is range of 10? 0 to 9. So 0 to 9 values I have printed. Okay, that means you can assign the range of values to a variable. So A is equal range of 10. For I in 10, for I in 10, I in A, you are going to print all the values which are stored in A. Are you getting?
Yes,
Sir,
sir.
now you may ask question. Sir, always range of 10, range of 20, range of 30, range of 40 will give from 0 to 439. Suppose if you write range of 40, 0 to 39. Suppose if you mention range of 100, that means 0 to 99. Yep. Are you getting? If I
Yes,
write
sir.
a range of 100, how many values you got? 0 to
100.
0 to
99.
0 to
99.
99.
Suppose if I write range of 1000, how many values you will get? 0 to 999.
0 to
Sir, what is this?
999.
Sir, what is this? Always I am getting from 0 to only. Suppose I want to keep values from 100 to 200. Can't I use? Can't I get 100 to
Yes.
200? Why should I always start with 0 only? Yes, range has till now I have explained one form of range. Now I'm going to explain another form of range. Okay, I think.
Suppose if you take, we can represent range in three forms. We can represent range in three forms. Suppose if you write a range of 10, that means if you mention only one parameter inside the range, then it default takes the numbers, sequence of numbers from 0 to 10 minus 1, n minus 1, 9. So it creates a continuous numbers from 0 to 9. So always it takes the begin as a 0 and it takes the end as a end value, that means n minus 1. So there is another, this is one way of using the range. So another way is range a comma b. So this is another form of range a comma b. That means from begin a to end minus 1, that means b minus 1. So you can create a sequence of elements, a sequence of numbers from the range a to b. Here a is included, b is not included. So a to b minus 1, a sequence of elements will be generated. So this is another form of range. There is another form, that is third form, range a comma b comma s. Here a is a begin, b is a end, and s is a step value. So step value means in what way you want. You want every alternate value, every third value, every 10th value. So like that you can mention your step operator so that it will give the sequence of numbers from begin to n minus 1 and by following the step value. So that is the step value. So these are the three ways of using the range. Already we have seen what is a simple range. Suppose if you write range of 10. Range of 10 means here you have not mentioned any here not mentioned any begin. So it is, the default begin will be 0 to 10. 10 means n minus 1. N minus 1 means 9. So 0 to 9. Suppose if you want to see the elements from the range for I in range of 10. For I in range of 10. Suppose if you want to print the value of I, you can print the value of I like this. So here 10 values are printed. Suppose if you see the second form of range, suppose 2 comma sum 10. That means I want to create the numbers from, I want to create a sequence of numbers in the range from 2 to 10 minus 1, that is 9. So 2 to 9 numbers I want to generate. So here I have used the second form of range. Suppose if you want to print suppose for I in range for I in range 2 comma 10, for I in range 2 comma 10. If you want to see the value of I, so you can see here I have created the values from 2 to 9. So I gave 2 to 10. 10 means it is an end. End means end minus 1, 9. So from begin to end. So closed interval to open interval 9. So here it creates the values from 2 to 9. So this is another form of range function. You can see you can create any number for I in range. I in range. Suppose if you write 10 comma 10 comma some 25. So here the piece I want to create a sequence of numbers in the range from 10 to 24. 25 means it is an end. So if you want to print the values, you can print the values. So you can see here it is created 10 to 24 sequence of number, continuous numbers. Suppose if you don't want the continuous number in the array, you have some step operator. You can use a step operator like this for I in range 2 comma 20. From I want to create a sequence of numbers from 2 to 19. From 2 to 19 I want every second element. I want alternate elements. I want every alternate element. So here I am writing. So you can see from 2 to 18, it has created every alternate value. So actually range generates the sequence from 2 to 19. But because of this step value, it creates every alternate 2, 4, 6, so on up to 18. That means every alternate value is printed. So that is the third form of range. Third form of range. So similarly, you can use, suppose for I in range 5 comma 100 comma, suppose I want every in between 5 to 100, I want every fifth value. I want every fifth value. So here I am just printing the values from fifth to, from the value 5 to 95, every from value 5 to 100, every fifth value is printed. Suppose you may ask, can't we print directly? Suppose if I take 2 comma 10, range of 2 comma 10. If you want to print range of 2 comma 10, you can see what is printed. So it is not printing anything. Why? Because range is a sequence object. So if you want to get the elements from the sequence object, you have to iterate over the sequence, and you have to bring one by one element by using any looping statement, either for loop or while loop. So for loop is best for bringing the elements from the iterator. So like this, you will use the range. So in this entire session, we discussed what is a float, complex, Boolean data type, and range, and the three forms of range. So in the next video, I am going to explain the excellent concepts of Python like lists, tuples, sets, dictionaries. In future videos, you will see more concepts of Python. So please watch my videos. Thank you for watching this video. I hope you're all watching my videos. If you like my videos, please subscribe my channel. Please share it, like it, and comment it, so that more students will be benefited. So you will get more updates from my channel. If you like my channel, if you subscribe my channel, thank you for watching my video.